Hey everyone! In this video, we are going to be looking at a right angle triangle and then trying to decide which ratio to use in order to solve it. So there are three common trigonometric ratios that we're going to use: sine, cosine, and tangent. And if all you've ever seen is the sin, cos, tan buttons on your calculator, this is what they stand for. Before we can decide which one we're going to use, we're going to have to put some labels on our triangle. So we put a theta for our unknown angle, and we put a little square, and that represents our right angle, our 90 degrees. When you're labeling our other sides, we put a little hip up on the diagonal, that's across from the right angle, and that represents our hypotenuse. Across from the theta is our opposite side. So just like the hypotenuse is across from the right angle, the opposite is across from theta, and the adjacent is the side that actually connects our theta to our right angle. Hada! If you can do this, you can correctly label a right angle triangle with the hypotenuse, the opposite, and the adjacent. Let's get a new triangle up here, however. Now we've moved theta up to the top of the triangle. How is this going to change our labels? Well, across from the right angle is still the hypotenuse. That big, long diagonal, always going to be our hypotenuse. But our opposite has moved. Because theta's up top now, our opposite's on the bottom, and the side that connects theta to the right angle, our adjacent, is over on the side. So there are three equations based on whether we're using sine, cos, or tan. The first, sine of theta, is equal to our opposite over our hypotenuse. Cos of theta is equal to our adjacent over our hypotenuse. And our last ratio, tan of theta, is equal to our opposite over our adjacent. In every situation, you have to be given at least two of the sides, and then you need to use that to decide which of the ratios you're going to use. So let's go ahead and throw some numbers up here, and you will notice that I only put numbers on two of the sides. It's up to us to decide which two sides those are. Based on where theta is, we can see that 20 is our hypotenuse. That means we have to choose one of the ratios that has hypotenuse in its equation. That's either sine or cos. Tan's no good, it doesn't have hypotenuse. Our last side, this 15, is the side that connects our theta to our right angle, which means our adjacent, which means our answer is cos. Our cos is going to equal our adjacent side, which is 15, divided by our hypotenuse side, which is 20. And that's how we set this up. We're going to go ahead and erase these and do one more example here. Keep theta where it is. We're going to put a 12 down on the bottom and a 5 on the side. Now which of the ratios would we use? We don't have the hypotenuse anymore, so we can't use one of the equations that uses the hypotenuse. Well, that means it can't be sine, and it can't be cos, because both of those involve a hypotenuse. That leaves the only equation left over being tan. So we know that the tan of theta is going to equal our opposite side, which is 12, and it's going to be divided by our adjacent side, which is 5. And that's how we set up and know that we need to use a tan ratio. I'll clear these out one more time, and we can do one more example. In our next video, we're actually going to work on solving these. For now, our goal is just trying to decide which one to use, whether you use sine, cos, or tan. So we put a theta down in the bottom left-hand corner, and we chucked up a 12 and a 30. We need to decide which sides those are. That 30 is a hypotenuse. That means we know we're either using sine or cos. We know that that 12 is opposite of theta. So we have a hypotenuse and we have an opposite. The only equation that has both an opposite and a hypotenuse is sine. So sine of theta is equal to 12, which is our opposite, divided by 30, which is our hypotenuse. And just like that, That is how we can decide which trig ratio to use. Check out our next video, and we are going to start looking at how we can actually start to use these ratios to solve problems.